The next kind of graph that we're going to look at are hyperbolas, and you can see that we have two different equations here. It should look almost identical to the ellipse equation that we had prior to this. The only difference is instead of adding the pieces, you're going to have one negative piece. So in this case, the y piece is negative, and this piece, the x piece, is negative. So it's the exact same equation of an ellipse, except for either the x or the y is going to be negative. Same thing for the center is going to be at hk. R of x is still going to be the distance on the x-axis. And likewise, r of y is going to be the distance on the y-axis. When you decide where to put the vertices, you are always going to put them on whichever axis is positive. So again, when you look at the equation, the first one, the vertices would be on the x-axis because that's the positive one. And our second one, the vertices would be on the y-axis because that is the positive one. The foci, we have c squared is equal to r of x squared plus r of y squared. Notice there's a slight difference. When we did the ellipse, you were subtracting. For hyperbolas, you are adding. That's a subtle little difference that if you don't pay attention, you're going to do the wrong thing given the ellipse or given the hyperbola. So pay attention to which kind of conic section you have and whether you should be adding or subtracting. Alright, so let's get started. We have our equation in standard form. We want the equation to be in graphing form. So we know that we're going to have it set equal to 1, so I'm going to move that 144 over to the right-hand side. And to make it set equal to 1, I divide everything by 144. And we get x squared over 9 minus y squared over 16 is equal to 1. Now this isn't quite into graphing form yet. When we look at graphing form, we notice that everything is being squared. Currently only the x is being squared. So we're going to put that 9 inside of the squared quantity. Well, what number squared gives us 9? I think we can all figure that out is 3 minus what number squared gives us 16. And yes, that is going to be 4. So we have our equation in graphing form. Our center, there's no number being added or subtracted from the x or the y, so our center is at 0, 0. R of x is the number underneath x, so our r of x is 3. Our r of y is 4. Our c value, remember the c value, we are adding the squares together. So 3 squared plus 4 squared gives us 9 plus 16, which is 25. That gives us c squared, so we take the square root of that to get our c as 5. The vertices are going to be the pieces on the x-axis, or not the x-axis, yeah, the x-axis because it's the positive axis. Before we get into the foci and the vertices, at this point I start getting the shape of my graph ready. So we know our center's at 0, 0. Our r of x is 3, so we're going to have a radius of 3 on the x-axis. And we have a radius of 4 on the y-axis. 1, 2, 3, 4. 1, 2, 3, 4. Now what's different about your hyperbola is we are going to create a box. So with those 4 points that we just made, I'm going to create an imaginary box. That's why I have a dotted line going on. Our graph isn't actually a box, so we're just going to use this box. That box is going to be there to help us create shape to our hyperbola. Now remember, the vertices are going to go on the positive axis, and when I look, they are on the x-axis. What this means is that on the x-axis, our vertices are going to be a negative 3, 0 and a positive 3, 0. If our y-axis was positive, then our vertices would have been at 0, 4 and 0, negative 4. So whichever points are on the x-axis or the positive axis, those are going to be your vertice points. Now our foci is a distance of 5 away. So from the center, we're going to count 1, 2, 3, 4, 5. And the foci are always going to go on the same axis as your vertices. And then we go left 5, and there are your foci. So foci number 1 is negative 5, 0. Foci number 2 is 5, 0. Now we actually don't have our graph just yet. What we need to do is we need to create our asymptotes. Our asymptotes come from this box. We are going to connect and do a line between each corner. If you want to use a straight edge, your ID works really well. And again, this is going to be a dotted line because an asymptote is not an actual line, it's an imaginary line. Okay, so our asymptotes are created by connecting the corners of that imaginary box that we created. So that's what before I said the box is there, it's kind of part of your graph, kind of not. What this does, an asymptote is an imaginary line that your graph is going to approach but never actually touch. So if this is the vertice of my graph, it's going to approach that asymptote but never touch. It's going to approach but never touch. We do the exact same thing on the other side. Approach but never actually touch. Now what we need, the last piece of information, we have our graph done, we need to write the equation of the asymptotes. If you're writing an equation, you want a point and a slope. Well, the point you're going to use, because it's always constant, is the center point. And our center here is 0, 0. The way that you get your slope from that center, I'm going up 4, right 3. So my slope in this case is 4/3. And we've got y minus 0 is equal to 4/3 x minus 0, which is just y equals 4/3 x. You're going to have two equations because you have two imaginary lines. Our second line is still going through the center at 0, 0, but this time our slope is down 4, right 3. So we have a slope of a negative 4/3. So we've got y minus 0 equals negative 4/3. X minus 0, y is equal to a negative 4/3 x. You can see that that up and that rise and fall comes from the r of x and the r of y. So you can always get that slope. You know, one's going to be positive, one's going to be negative. It's going to be the exact same each time. So let's review all of this. When we are putting this together, we see that we have our center. We have our r of x and our r of y. We use those two radii to create this imaginary box that's going to help us with our shape. We connect the corners of the box to create an asymptote in each direction. We look to see which axis is the positive axis. Whichever one is the positive axis, that is the one that we're going to put the vertices. And there are the vertices. The vertices are actually part of the graph. Then you add the squares of the r of x and r of y to get the foci, and the foci are going to fall inside of the pieces. Alright, so let's go ahead and move on to our next one. Turn your page over. Our equation this time we have set up is just a little more difficult. We've got 25x squared minus 9y squared minus 200x minus 36y plus 589. Again, we want to complete the square, so we're going to group our x's together and our y's together. And we're going to move that number to the other side, so a negative 589. We're going to use completing the square for every single conic section. It doesn't matter if it's an ellipse or a parabola or a hyperbola or a circle, you're going to use completing the square. So we pull that 25 out. I've got to pull it out of both pieces. So that negative 200 is going to become a negative 8x. That's what we're going to use to complete the square. We pull the negative 9 from the y. Negative 36 divided by negative 9 gives us a positive 4y. We're going to complete that square. And on the right we have the negative 589. We take half of our middle term, negative 4, we square that, so we're adding 16. But remember on the other side we've got to have 25 of those 16s. And then we take half of our middle term over here, which is going to be 2 squared, which gives us 4, so that's a negative 9 times 4. So just don't forget that you're multiplying by the number that you pulled out as well. We have that 25 still on the outside. When we factor that, that becomes x minus 4 quantity squared minus 9 y plus 2 quantity squared. When you add all those numbers up together, and make sure that you're really careful when you're plugging your numbers into your calculator, when you're adding, when you're subtracting, whether you have positive or negatives, that gives you a negative 225 on the right. We want it to be set equal to a negative 1, so we divide everything by a negative 225. So we've got x minus 4 quantity squared over a negative 9. And negative over a negative makes that positive piece all over 25. And then we've got our one last step of putting that into actual graphing form. The negative stays on the outside. 3 squared gives us 9. 5 squared gives us that 25. So now this is going to be our equation in graphing form. We know it's a hyperbola and not an ellipse because we have a negative piece there. What I want you to do now is see if you can fill in all of that important information. I would, at this point, stop, go to your graph, and plot, see which ones are your vertices, and then go to your foci. Alright, go ahead and press pause and see if you can finish that. Alright, let's see how you did. First thing we want to find is our center. Opposite of negative 4 is a positive 4. Opposite of a positive 2 is a negative 2. Our 3 is our r of x. Our 5 is our r of y. We square them and add them together. That gives us 34. That's c squared. We want c, so we square root that. We're going to use the decimal because square root of 34 is not really going to help us too much on our graph. So what we know right now at our graph we can start with is our center at 4, negative 2. Then we can plot our r of x going right 3 and left 3. And our r of y going up 5 and down 5. I would then go ahead and connect those 4 points to create that box. So after the center, the r of x and the r of y, I would start by plotting that before I move on. Once we have our box, we connect them with our imaginary line of our asymptotes with a dotted line. Remember, anything that's not really there is going to be a dotted line. And then I'm going to decide where are my vertices going to go. I look at my equation. The y is the positive one, so that's where the vertices go. That's why I have 4, 3, and I have 4, negative 7 as actual parts of my graph. Those are going to be the vertices. And the vertices are actually going to be part of the graph. That is the point that you're going to use. You use that point and approach the asymptote on each side. Use that point, approach the asymptote on each side. And we found that that C was 5.8. So from the center, the foci are going to go on the same axis as the vertices. So we count up 5.8, we count down 5.8. What you want to be careful about is that you don't use the foci to draw your parabola. I see it all the time where you go like this instead, and you will be marked wrong. The vertice is part of the graph, the foci is inside of that graph. Alright, now we're going to find the coordinates of those foci. Since the foci are on the same axis as the vertices, we are changing the y coordinate of the center. So we add that 5.8 and we subtract the 5.8 to get those two foci coordinates. And the last thing that you have to do is find the equation of the asymptotes that we drew in. You're going to use the center and your slope. The slope is just how much you're going up and over. These two numbers are going to be the exact same, except for you're going to do the positive and then you're going to do the negative. You're going to use the center each time. You can go ahead and leave the equation in point-slope form, or if you prefer, you can go ahead and put it into slope-intercept form. Either one will be correct on your quiz or test. All right, and that is all for our hyperbolas today.